good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without wasting much time, we will be quickly moving on to our topic of discussion. As you have already seen in the previous lecture, we have started the chapter Motion in One Dimension, and we have briefly discussed the idea about rest and motion. So I think the concept that rest and motion are two relative terms has been clear to all of you. Okay, and before starting the lecture, we have a simple request that please do like our videos and share these videos with others so that everybody can learn from these videos. Okay, so with that, let us begin our lecture today. Okay, so what is the topic of discussion today? We will be discussing about distance and displacement. Okay, fine. Now see, in the first chapter, while learning about the various types of various types of physical quantities, we have discussed that there are two categories of physical quantities: fundamental and derived. And another way by which we can categorize physical quantities is that vector and scalar, isn't it? So I think you have remembered the concept of vector and scalar. So basically today what we are going to discuss, distance and displacement, are these two quantities are actually one of them are actually vector quantity and another one of them is a scalar quantity. Okay, so let me just discuss, and I will be asking this question once again to you at the end of the lecture. I hope by the end of the lecture you can yourself answer the question that which quantity is a vector quantity and which quantity is a scalar quantity. Okay, fine. Now what is distance? Okay, so in simple terms, if we say what is distance and displacement, see, if you want to go to your school from your house, okay, you can actually go by, there are many roads. Okay, there are many roads, so you can go by any one of those roads. The time taken by you to reach from your house to your school by traveling the various roads may be different. Okay, but all of those roads actually lead you from your house to the school. So just let me illustrate this by a simple diagram. Okay, so say this is your house. Okay, this is your house, fine, this is your house. Okay, and this is your school. Okay, this is your school, fine. Now actually there are say 2 or 3 roads by which actually you can reach your school. Okay, say one road goes like this. You first go in the south direction. Okay, then you go to the east direction. Okay, and you reach your school. Okay, this is one of the road. Okay, so another road is there which may be like this. First you go to the north direction, then to the west direction, then to the south direction, and then finally you go to the east direction and then to the north to reach your school. Okay, the road marked with black color may be a little longer. It may take a little bit more time for you to reach the school, but definitely it will end up at your school, isn't it? So you will reach your school anyhow. If say the road marked with blue paint is being repaired at some point and it has been stopped, it has been put and it has been stopped for the repairing works. Okay, so you have to go by this road marked with black paint. So that may be another way of reaching your school. That may be another way. You can also say there is another way like this. You go to the east first, okay, and then a little bit to the south, then again to the east, and then to your school. Okay, so these are the various ways. Okay, fine. Now, so what happens when you are actually following these roads? You are actually traveling these distances, isn't it? Say this distance maybe say this distance is first you go 3 kilometer, okay, to the south, then 4 kilometer to the east and you reach school. Okay, so total distance, total actually path that you have traveled is 7 kilometers, length of the path. And then these two roads may have different lengths. This road is a bit longer, this may be say about 12 kilometers, or this may be say about 10 kilometers. Okay, so like this. Now these are the roads. These are actually the roads by which you are traveling. You may be going by car, you may be going by an auto rickshaw, or you may be going by motorcycle, or you may be going by the school bus, whatever the mode of transport may be, but you are actually moving through these paths. So these paths are called the distances to your school. Okay, so this 7 kilometer, 12 kilometer, 10 kilometer distances. Now if I say that there is a helicopter facility available to you, and you can actually directly fly in the in this direction, so like this, in this direction. Okay, in this direction. Okay, in this direction you can fly. Okay, so if you directly fly in the southeast direction by a helicopter, the helicopter will not actually follow these roads. It will just take off into the air and directly go in the southeast direction and reach your school. Okay, fine. There is a playground in your school, it will just land on the playground. So in this case, isn't it that the distance traveled by the helicopter is the shortest? Okay, definitely is the shortest. Okay, and you see you can actually observe that here a right angle triangle is being formed. If this is 3 kilometer, this is the perpendicular, 4 kilometer is the base. So definitely this path indicates the hypotenuse, okay, of the right angle triangle. So how much it will be? If you apply Pythagoras theorem, it will be 5 kilometer. Okay, there is a theorem in mathematics, as you know, Pythagoras theorem, by which you can apply and find out the length of the hypotenuse. So it's 5 kilometer. Okay, so this is the way by which you can actually travel to the school using a helicopter. So and while you are traveling in the helicopter, there is the shortest distance. That is, when you go through air, you are not following any road. You are actually taking the shortest distance. So this shortest distance that you are actually traveling is the displacement. I hope the concept is clear. So the path marked by the red color is actually the displacement. So that is the shortest distance. Okay, so that is the displacement. Okay, now if you are saying that displacement, then definitely from the house to your school, the displacement have a definite direction, that is along the southeast. If you just move into any other direction, it will not work. Okay, fine. So this is the thing that you can do, that you can actually take the shortest route and reach your school. So that is displacement. So by now I think the concept of distance and displacement is clear. Now let me just erase this example and give you the definition of the distance and displacement. I hope you have copied the diagram. If not, please copy the diagram. So just note it down that the red colored path marked is actually the displacement. Okay, red colored path marked is the displacement. Okay, and the others are the distances. Okay, the blue colored or the black colored, these are all distances. Okay, fine. Now I am just erasing it off. If you have not, please pause the video and note it down. Okay, so now if I come to the definition of distance and displacement, so what will be the definition? See, when we are talking of distance, it is actually the path traveled by you while moving from your house to the school. Okay, so distance is the actual path. Okay, actual path traversed. Okay, actual path traversed. Okay, while moving from the start or the starting point of journey to the end point of journey to destination point. Okay, to destination point. Fine. So this is actually the distance. Okay, now if you consider displacement, okay, so displacement is actually the shortest, it is the shortest path, not the actual path that you are traveling. Even if you don't travel through that shortest path will always exist between the starting point and the end point, isn't it? So displacement is regarded as the shortest path between the starting point and end point of a journey, okay, of a journey, okay. So this is the definition of displacement, isn't it? So you have already seen that distance. So can you say that whether displacement be greater than distance? No, definitely not. Distance will be always greater than displacement. At the most, the distance can be equal to the displacement. See in the case that the hypotenuse that we have drawn by the red line, okay, that may be actual road connecting your house and school by that red line, okay, along that red line. So that road is actually the shortest road between your school and the house, okay. So that is the shortest path that you can travel, okay, and that shortest path will be regarded as the displacement, okay. So that can be when there exists a road along that red line, that is the distance when you are moving through, and that is also the displacement, okay. So distance can be either greater than or at the most equal to displacement, okay. So distance can be either greater than or at the most equal to displacement, fine. So this is the basic concept, okay. Now coming to the next point, that as I said in the starting of the lecture, that between these two quantities, one of the quantity is actually the vector and another quantity is actually the scalar. So now can you think of which one is a vector and which one is scalar? I think now you can answer. See, while we are talking of distance, there is no definite direction, okay. There are many directions. While traveling from the house to school, there are many directions in which you can go. So there was no definite direction. But when we are saying displacement, there was only one way by which you can find the displacement, and that was the by traveling from the house to the school in the southeast direction. So displacement has a definite direction associated with it, but the distance has no direction associated with it. So I think the concept now is clear, that the distance is actually, so this is the first point, this is the second point, okay. Distance is actually the scalar quantity, okay. So it is the scalar quantity, isn't it? Scalar quantity, fine. Scalar quantity. On the other hand, this displacement, isn't it? Displacement is the vector quantity. Okay. So this is the vector quantity, fine. So displacement is the vector quantity, fine. So these are the 2 points that you must note it down. Okay, so I think the concept of distance and displacement is clear, fine. Now think of it like when you are moving from one place to another place, okay, say from your house to school or any other place. While you are traveling, distance can never be zero, isn't it? That when you are traveling from one place to another place, if those are two different places, actually the distance can never be zero, okay, isn't it? But when you are traveling in a journey, the displacement can be sometimes zero. You might be thinking how it is possible. Just let us take another example, diagrammatic example, okay. So consider another example. So it's like this, that okay, now say this is your house, okay, and this is your house, fine. Now you want to you have been in your house locked up for quite a few days. Now you want to just move out, take some fresh air and come back to your house. You might be studying rigorously during the examination, but on a certain you are feeling very bored and you need to take some fresh air, you need to go out. So what you do, you go out of your house, okay, and say you move 2 kilometers to the east, then again 1 kilometer to the south, okay, then say again you go around 2 kilometers to the west, and then you come back to your house 1 kilometer to the north, okay. So this is your travel plan, okay. Now see one thing here, during the total journey, the distance that you are traveling, the actual path that you have traveled or you have traversed is actually what? 2 plus 1 3 plus 2 5 and 1 is 6. So the total distance that you have traveled is 6 kilometers, isn't it? But can you think what is the starting point and what is your end point? House, okay. So you have started from the house, you have come back to the house. Now if I say what is the shortest path between the starting point and the end point, your starting point and end point are both same, isn't it? Then definitely the displacement in this case, it will be what? It will be 0. So the displacement in this case will be 0. So see, you can see that the distance, there may be when you are actually traveling, there has to be some value of distance, but the displacement maybe sometimes it can be 0. Another example that I can demonstrate is that if you just think of an ground, okay, and there are tracks on which the athletes can run, okay. So in that case, say this is a circular track, okay, this is a circular track, okay, circular track of certain radius, okay, circular track of certain radius. So just let me draw it first, then I will be discussing circular track, okay. And this circular track has a say radius of say suppose half kilometer, okay, or say let us consider as this, okay, half kilometer. So this track has a radius of half kilometer, okay, fine. Now so when you are say an athlete starts from this point, okay, he or she just runs around, okay, runs around and comes back to the same starting point, fine, comes back to the same starting point. Now what happens during this whole exercise, what the athlete actually covers is the circumference of the circle. So the distance here will be equal to 2 pi r, isn't it? And so that will be equivalent to 2 into pi, say suppose 3.14 into r means half kilometer. So 2 cuts out, so it stands out to be 3.14 kilometer is the total distance that he or she has traveled. However, when you are considering the displacement, it is actually 0 kilometer, because where the athlete have started, the end point is the same, isn't it? So in this case, the athlete has a displacement of 0 kilometer. So this is another example. While you are moving on a circular track, and if you move on complete circle, okay, you are actually having a 0 displacement, but you have actually moved out certain distance, okay. So just let me end the lecture with a question for you, okay. So say if the athlete has actually traveled 1.5 revolution, so the athlete had started from this point, this is the starting point, okay, this is starting point, fine, and the athlete goes round like this, one round and then another half round, okay, and he or she ends here, okay, so this is my end point, okay, okay. Now the question for you is that what is the total distance traveled by the athlete and what is the total displacement traveled by the athlete, okay. So if you actually can answer this question, please do mention in the comment box. We will actually see your answers and say whether it is correct or wrong, okay. So we will be giving the answer of this question on the next day, okay. So please do remember it, and okay, so we will be ending our lecture here. till the next lecture, please do study well, and if you have any query, please do not forget to mention in the comment box. Like the video, share the video as much as you can, so that it reaches to the person, to the students, to all the students who need this, who need some basic concept clearance. Okay, so for that, please do share the video. Okay, with that, we are ending the lecture here. We will be continuing the next lecture from here. Till then, thank you, take care, goodbye.